In this lesson, we will discuss energy changes in chemical processes. In physical processes, the bonds broken during melting and vaporization are the intermolecular forces of attraction, but not the strong covalent bonds between the hydrogen atoms. In chemical processes, the covalent bonds are broken and new ones are formed. Enthalpy change in chemical processes are determined through experiments. The value of enthalpy change, H, depends on the pressure and temperature in which the reactions are carried out. 250 or 298 Kelvin and 1 atmosphere are referred to as standard temperature and pressure respectively. Enthalpy changes measured under these conditions are known as standard enthalpies, denoted as delta H. To determine the final quantity of energy released or absorbed during a reaction, we need to know the amount of energy used to start the reaction and the amount of energy released at the end of the reaction. We then compare the two amounts of energies obtained to find out whether the energy used to start the reaction is more or less than the energy obtained. Bond breaking and bond formation. Molecules have covalent bonds. For the molecules to react, the covalent bonds must be broken first, and this always requires energy or endothermic reaction. Reactions leads to formation of new products with new covalent bonds, and bond formation is always accompanied by heat loss to the environment, hence exothermic reaction. For example, in the reaction between hydrogen gas and chlorine gas to form hydrogen chloride gas, the HH and Cl-Cl covalent bonds are initially broken, followed by the formation of HCl bonds. The table below shows the bond energy of different covalent bonds. In this lesson, we will discuss enthalpy of solution of compounds. When a substance like sodium chloride dissolves in water, the water molecules interact with the sodium ions and chlorine ions in the solid. The energy of interaction overcomes the forces of attraction between the sodium ions and the chlorine ions, and the ions are separated from each other. Each of the separated ions is then surrounded by several water molecules. The overall energy change may be exothermic or endothermic and is called enthalpy of solution. The following experiment was carried out to determine the molar enthalpy of solution of sodium hydroxide. Click to play the video and observe what happens carefully.
The following video clip shows an experiment to determine the molar enthalpy of solution of sodium hydroxide. The apparatus and chemicals needed are 5 grams of sodium hydroxide, a thermometer, a measuring cylinder, a glass rod, a plastic beaker, and distilled water. Procedure: measure 100 cubic centimeters of distilled water and transfer it into a plastic beaker. Measure the temperature of the water and record it in the table. Add all the 5 grams of sodium hydroxide in the water and stir. Work out the temperature change.
Heat of solution is the amount of heat evolved or absorbed when 1 mole of a compound is completely dissolved in water so that further dissolution causes no further temperature change. The following is a worked-out example showing step-by-step process on how to calculate the heat of solution using sample results from the video observed. The following is a worked-out example showing how to calculate the heat of solution of a given amount of sodium hydroxide dissolved in a specific amount of water. The following is a worked-out example showing how to calculate the heat of solution of a given amount of ammonium chloride dissolved in a specific amount of water.